a shot. Cold out there today, so let's close this pneumonia hole and get a little warmth going. Alright, about a year and a half ago, approximately 5,000 miles ago, I removed and replaced the stock point type distributor that was on this 54 235 engine installed in this 49 Chevrolet pickup, and I installed a Pertronix Flamethrower distributor with an Ignitor II electronic ignition and a Flamethrower II coil. And I'm going to do a little bit of a review on it and let you all know how it's doing. So stay tuned. Like I already mentioned, I received and installed this back in, what was it, August of 2020, and I've put about 5,000 miles on it since then. I've done an oil change, some preventative maintenance. But one good thing right off the bat that I didn't have to do was concern myself with the points. There's no points to be concerned with. Just a simple inspection of the inside of the distributor cap and the rotor button to make sure there was no arcing and sparking. So let's take a look at that and see what it looks like. All right, I'm going to show some close-ups of the install. One of the things that'll jump out at you over the stock distributor is of course, this is a modern distributor, so the vacuum advance mechanism and how it advances the mechanical flyweights is all done internal, like modern GM distributor of that era, and instead of the whole distributor turning. So you can see it's kind of a modern vacuum can. And here on this side, I still utilize the stock octane adjustment to do the timing. You see I've got a little black line put there that lines up evenly with the marking on the zero marking on the block. That tells me, number one, I haven't slipped any, and we're going to put a timing light on it anyway and double verify, but according to that I haven't slipped or moved any. And there's any excessive oil or any leakage, and so physically, and this spark plug kit, these HEI spark plug wires. Now they were actually, I ordered them custom to fit a 54 235 engine, and you can see they fit just fine. And here is the Flamethrower II high voltage coil from Pertronix. That comes in a black like this or chrome. And chrome would have worked on this, but black works good too. And it actually bolts in the stock standard 6-volt coil bracket that connects to the block. So we're good there. All right, the distributor is real similar to the GM style distributors before the HEI, the point type, and I'm going to remove the cap. It's got two spring-loaded clips, just like the GM style of the time, and easily remove the distributor cap. And there's the rotor button. Now let's look inside there and see what it looks like. And you can see there's no white deposits. I don't see any kind of carbon tracking. I mean, it looks in very serviceable condition, and that's after about 5,000 miles, like I said. And the center electrode's good, and all 6 of the spark plug lead stubs there are good. So we're good there. Now let's look down here at the rotor button, and if you can look here good, you can see there's no black or arcing and sparking around it. It's making good contact right there in the middle. You can see that little dot where it's hitting, and you can see the edge here. So we look good there too. So the cap and the rotor button are nowhere near needing replaced. So let's take a look at the flyweights underneath. All right, they take a standard Phillips. This is a standard GM style rotor button that was pre-HEI, so you can get them at a standard flaps. And there's the underside. There we go. It's a better look at the tip. Burning real good, no problems there. Now I'll do a close-up of the flyweights. Now what we've got here is, you see I've got the copper flyweight springs, and these are limiters. Now I'll go into more detail about why I changed the springs and installed the limiters, and I'll do that here in a moment or two. But I just want to point out that they still look good and serviceable, and I don't see any problems with that, and nor any other problems inside the distributor. So the physical inspection of the distributor, there's the Ignitor II pickup right there, electronic ignition, and there's a good ground wire there. See, everything looks good as far as this inspection, so I'll get in more detail about the springs and the limiters on that distributor. All right, now I'm going to explain how I got the distributor set up to fit this particular engine. Now, if you notice, the 2 springs are the copper colored springs, okay? I just wanted to point that out, that these are the copper, and I'm going to show you the other, and these are number 8 limiters, number 8. So we've got copper springs and number 8 limiters, and I'm going to explain that to you now. All right, I'm going to explain how I fine-tuned that distributor to work better with my modified engine. Like I stated, the distributor out of the box came set up and would probably work great for a stock 235 engine. I don't think you'd have to do, or 216 or 261 for that matter. I don't think you'd have to do any additional fine-tuning to it. But since my engine is modified and I had the inclination, I decided I'd play with it more. Started off with, I wanted to, since my engine is modified, there's no factory timing setting that I could use to set the timing. I had to use several different methods to get the timing in the ballpark to where it would work the way I wanted it. I used the max vacuum procedure. I used hit and miss on road tests, and I also used the max mechanical advance. And it ended up that I used a combination of the max mechanical advance plus the road test, ping test, to get my timing down. And that's what I did when I put the points in, and I determined that running 10 to 12 degrees before top dead center was the optimum setting for this particular modified engine. So when I put the Pertronix in with the silver springs, that's how I set it up. I first went to 10, then I decided to go to 12 degrees before top dead center to see if I could get a little bit more power, and it seemed like it was quicker, and it seemed like it was fine. And I probably could have left it like that, but I decided I was going to play around with the timing some more. And in studies, I determined that I was wanting to shoot for a goal of a max mechanical advance timing of 30 degrees before top dead center. Now that's with the vacuum disconnected. The vacuum is not involved in this setting. It's all mechanical. So where the idle timing would end up being was irrelevant, as I was mainly looking for the max mechanical. And on the 6-cylinder, I determined that 30 degrees to 32 was my goal. So in doing tests with the silver springs and no limiters, I was coming up with at 12 degrees before top dead center, I was coming up to about 36 degrees before top dead center is my max mechanical advance, and I determined that was a little bit too much. I got a little bit too much valve pinging going uphill under load or in hard acceleration. If I let off the accelerator, it would go away, but I decided I wanted to see if I could not only fine tune it better, but maybe get a little bit more quickness. So I'm going to point to the kit first. All right, well, first I'll point to the to this graph that comes with the distributor, and it also comes with the if you order the spring and limiter kit, the instructions also come with it. But anyway, we're going to look down here, and I hope it's focusing good. Here you can see at different RPMs where the springs, how fast they advance mechanically through the RPM range. And if you notice, like I say, you may not can see it good, but the copper springs, they advance quicker at a lower RPM to get to the max advanced. The next line you see here is the silver, and the last line you see here is the black. And let's see, actually, I'm sorry, this middle one here is a combination of copper and silver, and the very last is black. So what that tells you is if you want your fly weights to open quicker at lower RPM, you'd go with the copper. Silver is what it came with from the factory, and that's right there in the middle pretty much. You see, you could drop it a little bit more if you made a combination of springs, and then you could drop it a lot with the blacks. The only time I think you'd want to go to the black springs is if your engine really pinged bad, and no matter where you put your timing, and you just needed to keep the fly weights from opening as quick, so you'd go with the black. But anyway, I decided since the 235 makes a lot of power at the lower RPM, I wanted to try to get that advanced invoked a lot sooner, and perhaps I can get some more quickness. So what I did was, like I said, it comes with the silver springs out of the factory, and there's the black ones, okay? So I removed these silvers, and the copper springs were in the pack. I installed them. Now what I got was, by installing them springs, I still got a maximum mechanical advance of around 36 to 37 degrees before top dead center, which is too much. But I really liked the quickness. I could tell by the seat of my pants that the quickness was definitely improved. So instead of going back to the silver springs or backing down the timing to where I would lose performance at the lower speeds, I decided I would invoke these limiters. All right. Now over here, if you look at the limiters, 3 sets of number 6, number 8, and number 10. Basically, with no limiters, I was sitting at around 36 degrees before top dead center, maximum mechanical advance at 3,000 RPM. All right. Now, after above 3,000 RPM, you've hit your maximum advance, and it won't advance anymore. So that's basically where you do your setting. So what I did was, since I'm set at my initial of 12 degrees before top dead center, I decided I'd use these number 10s, which according to this literature will limit the the weights at 20 degrees before top dead center, would actually limit the amount they had opened to 20 degrees. Now, you add that plus the 12, that would be around 32, which was pretty good. So I put the number 10s in and tried them, and I was getting around 34, which was still giving me valve ping when I really didn't want it. And so I decided I would try the number 8s, which supposedly limited to 16 degrees, okay? So you got your initial of 12 plus 16, you're looking at what? 28 degrees, okay? So I thought, all right, we'll try that and see what it does. Well, in my case, it limited it to about 30.2 or 5. I can't remember the point, but it was 30 degrees before top dead center, was in the ballpark. And my valve pinging was very, very slight. I barely would notice it under maximum load going up a hill. So I thought, oh, there you go. That's where I want. Now, when all these tests are done with the vacuum disconnected, so by reconnecting my vacuum, you gain about an additional 10 degrees, okay? And most of that invokes at lower speeds before your mechanicals come in, okay? But they do add 10 degrees total, more of total advance. So that brings me to about 40.5 degrees maximum advance on my distributor, and that seems to be a very sweet spot with this particular engine. So anyway, that's basically, I've done about probably 3 videos where I was doing these, and I'll put them in the description, where I was fine-tuning that distributor. I'd try something, run it a while, then I'd try something and run it a while. And finally, my final setting, which I am very happy with and which I've been running now for about probably, I don't know, 4,500 miles, is 12 degrees before top dead center is my initial timing. 30 degrees, 30.5 degrees is my max, before top dead center is my maximum mechanical advance, and 40.5 degrees is my maximum total vacuum and mechanical advance. And this engine really seems to run good on it. And I'm also running 87 octane. Now, the little bit of ping that I still have under max load, which I very rarely encounter anyway, I could probably go to a more higher octane gas and do away with that. But my goal was also to keep 87 octane and keep it, keep the price down as much as I could, because, the way gas prices are, you don't know how they're going to be. So anyway, the documentation is real good. You got the graph here, and it's got a good description on how to do what I just described. Good description on how to install it on 6 cylinders, V8s, just about anything that you want. And it even has a spare parts list back here. It's their parts, but you can cross-reference it to the GM OEM type, which is a good thing. And again, I also, when I was doing these settings, I removed and replaced those copper springs several times to change out these limiters, and ends up that I stretched them too much. So I was able to order a new kit off Amazon, and it was not that expensive. It was pretty reasonable for a whole kit, and the kit came with a whole nother 3 sets of limiters, 3 sets of springs, and the electrical terminations, plus the instructions to do the install. So bottom line is, if you do play around, if you do go this route and you play around with the springs and you stretch them, you can order a whole new kit. And you can't order just the set springs you want. You got to get the whole kit, unfortunately. But the kit's not that expensive anyway. I want to point out one additional thing. Anytime you see a bold type, you want to really pay attention to it. It's just like the Bible. If it stands out, you should pay attention to it. But anyway, the first caution to look for is you cannot use solid core spark plug wires. Now, that's what the stock 235s, 216s, and 261s utilize. So you have to go to an HEI type high voltage plug wire if you go this route. The second thing you look at is it comes with a hardened steel gear, the distributor drive gear, and it's also another term for that is melanized. Now that's a good thing, because if it was not a melanized steel gear, it would not mesh with a lot of the cams that we use in these. We do use cast cams as opposed to steel cams. So in some cases, running a steel gear that is not melanized will wipe out your cam, the gear on your cam, if it's a cast gear. But a melanized steel gear will work with a cast cam. And like I say, after 5,000 miles, I have not had an inkling of problem with it. But that is something to keep to be aware of. And again, hopefully this chart shows good. This does come with the distributor, and it also comes with the spring kit if you so desire to go that way. And then it'll explain how everything, how you can set it up. But in my case, with the copper springs, you can see how quickly my advance is invoked, and that coupled with the vacuum advance at those lower RPMs has given me, you know, about all the quickness I can expect to get out of a 235 engine. So anyway, those of you that aren't familiar with my channel and this engine, I want to point some things out with this engine so you'll know why I played around with I didn't leave the distributor with the silver springs and no limiters, and I played around with it. This engine is, I rebuilt it about 7,000 or 8,000 miles ago, did a total rebuild. It's got the higher compression 848 head on the stock 1954 235 block. I had it bored 60 over to clean the cylinders up, which takes the total cubic inch out to about 244 cubic inches. All right, and I went with lightweight aluminum pistons to even get the drivetrain even a little lighter. The rods are stock, the crank is stock. Now the cam that's in it is a what they call a 3/4 race cam, a Bulldog 3/4 race cam with I think the exhaust duration is 264. That's another way they measure it. So it's a 264 3/4 Bulldog race cam. And in the big scheme of things, when it comes to cams, you'll have like a stock 261 cam, which is a hotter cam than the stock 235 cam. So you'd have that stock 261 cam, you'd have the 3/4 race cam, then you'd have the thump. I decided I didn't want the thumper, so the 3/4 race cam is sort of middle of the pack. And I get a good smooth idle at 650 RPM, 600 to 650 RPM, which is what? 150 to 200 more RPM than what a stock 235 would idle. But that's fine, because I can idle this down to 400, 450. But it's sounds, it's got a, you know, that cam's just too radical to, and I like it smooth. So anyway, those are Carter Weber progressive 2-barrel carburetors, dual, on Fenton dual intake and a Fenton dual exhaust manifolds. Let me see if I can get a light under there and show you better. Okay, you can see the dual exhaust right there underneath the intake, and you can see I do have it heated. It's not a really good way to preheat, but it's better than nothing. And it's a true dual exhaust all the way to the back, and those are 3232 progressive 2-barrel carburetors. So when it's running at idle and at very low speeds, it's running on the single barrel on each carburetor, basically a 2-barrel. When I open it up, it'll open up the mechanical secondaries, and it's the equivalent of a 4-barrel. And it does run pretty good. It does not top out. It does have more than 4,000 RPM. But I don't take it above 4,000 RPM often, because I still have the stock torque tube, 3 on the tree and 411 rear end, and it's really spinning to get up to there. But I have buried this at 80 mile an hour several times, and it had more to it. So anyway, that's kind of why I've played around with that distributor like I have. Yeah. The rotor only goes on one way. Okay. And the cap is notched, and it only goes on one way. So, and there we are. We're back, and that's basically the preventative maintenance on one of these units. All right. Just put it back together. I'll just show you how easy it starts. Now the engine, I have been running the engine. It is warmed up, so it should start real easy. I didn't even touch the gas. It's so cold outside, and the engine's been off for so long. That's why I can't kick it down. We'll let it. We'll try to kick it down one more time before I shut it off, because it's so cold out there. I want to keep the shop closed up, keep my heat in. Well, that's not the actual, the true idle. If I put my tack on it, it would probably, well, I'll tell you what it's reading. Right? It's about 1100 RPM. When it's ice cold, when it's on the fast idle, it's about 1500 RPM. Now it's 11. Like I say, once it warms up, I'm down around 600 to 650, somewhere around in there. I doubt it'll kick down there yet. I'll give it a shot. If not, I'm still going to shut it down. Well, there you go. So there's the true RPM. Let me check it on my tack in here. It's between 600 and 650. It's pretty much in between the 600 dot and the 700 slot. So there's your idle right there. And you can see how smooth it is. There you go. Now if I take it down to where a stock engine's at, that won't even stay on there. It has that lope to it. All right. Now I'm going to show you that. Okay. Needless to say, I'm very happy with the performance I'm getting out of this engine with that Pertronix distributor. Now, oddly enough, the point distributor that I had in it, I was not experiencing any problems with it at all when Pertronix approached me to try this unit in one of these Stovebolt engines. Stovebolt engine, being a 216, 235, and the 261 series of engines Chevrolet put out back in the 30s, 40s, 50s, and up into the very early 60s. Actually, these engines have been around quite a while. But they hadn't had a full distributor replacement for it, and they wanted a test bed. And I guess they must have seen one of my videos on YouTube and decided to give me utilize me and my brand new rebuilt engine to try it out. And it's been a very overwhelming success in my engine. Again, it came with the silver springs on the mechanical flyweights, and I believe that's probably what you'd want on a stock 235. I don't think you'd want to go to those coppers. Of course, you know, unless you have the cam and carburation and exhaust to take advantage of it, well, you can always play around with it anyway. But it's been the point type distributor I had in it, it was fine, but I noticed immediate improvement in not only in performance, but in hot starting, cold starting, ice cold starting. And I'm still running the stock plugs, and I'm running 35 thousandths gap. I decided to stay at that gap, although I think I could probably go to 45, but I don't see any you know, I may experiment with that some and see, but I am still at 35 thousandths. And the electronic ignition coupled with that higher voltage coil, well, you know, this thing fires right off the bat. I mean, I drive it year round. Don't matter if it's 90 degrees outside or 0 degrees Fahrenheit. I'll drive it because I got a good heater in it and good radio, and I got great roads that I like to cruise on, and it's very relaxing. So anyway, but to get back to this Pertronix, the distributor, like I say, my distributor wasn't giving me any problems, but it was the stock 54 distributor. And what happens with those distributors is the bushings, they can wear out, and you can start getting wobble in the shaft. And you'll start noticing crazy intermittent misses and maybe some hard starting. Depending upon how loose that shaft can be is how much it'll vary the point gap on them points. So not only do you get electronic ignition, you do away with the points in your distributor, but you also get a distributor with all new bushings and shafts and no play. And you get a more modern vacuum advance instead of the entire distributor swiveling. You're more modern in the, you know, it's all encased internal to the distributor cap. So there's a lot of advantages to go into something like this. Now there's a lot of other aftermarket providers with distributors. Pertronix even makes a Ignitor II module that'll drop in your stock distributor. But if you're having any kind of issues with your distributor, you may think about going with this. Now what I'll do in the description, I'm going to put the part number. It's kind of hard to look up on their site. It was for me. They had provided me the part number, and when I search by that, it takes me right to their page. So I'll put that in the description, and I'll also show it here momentarily during this film. Stay tuned. Alright, one of our rare ventures onto the interstate in the Chevy. Let's see what it'll do. Rough road. Alright, we're doing 65, no problem at all. and I can't run around anybody. I can't open it up.